Welcome to Sir Dave's Math. Today we shall be looking at angle of elevation and depression. So let's start this way. Let's assume that a boy standing on an horizontal ground tries to look at a kite on a palm tree. So let's this be the palm tree, and there's a kite on top of that palm tree. Without looking upward, this boy has a line of sight. That is where his eyes can see, or the level or the plane his eyes can see without tilting his head. And then now the boy wants to take a look at the kite on this palm tree. This boy will have to raise his head up a bit or tilt his head up a bit to be able to see the kite. Now the angle formed between his line of sight and the kite is called angle of elevation. The angle formed between where he sees the kite and then his line of sight. This is called angle of elevation. So let me take out this palm tree and take out this boy and draw this right angle triangle like this. So let's call this place A and put an observer there, and then let's call this B and put our object there. This line AC represents our line of sight. So for angle of elevation, it is the angle formed between line AC and line AB. Let's call this theta. Now for angle of depression, we'll do the reverse of this. So let's assume that there's a boy on top of this palm tree who is trying to look at an object on the ground. Where this boy is, he has a line of sight. Where this boy is, he has a line of sight. Now if he wants to look at this basket, probably basket of fruits, he will have to tilt his head downward to be able to see the basket. So the angle formed between his line of sight and that basket is the angle of depression, or is called angle of depression. The angle through which he moves his head downward to be able to see this basket is called the angle of depression. So I'm going to replace this diagram or this drawing with a triangle, a right angle triangle. So we have our observer here. Let's call this A, let's call this B, let's call this C. We have our object here. Now this is our line of sight. This angle is what is called angle of depression. So let's solve problems. Let's solve problems on angle of elevation and depression. Now the use of this topic is to enable us calculate the heights of objects and then the distances of objects. And in doing this, we'll need our trigonometric ratios, what we've done in our previous videos. Now let's look at a few problems on angle of elevation and depression. So our first problem says a ladder leans against a vertical wall at an angle 60 degrees to the floor. If the foot of the ladder is 8 meters away from the wall, calculate the length of the ladder. So we'll sketch the problem. Always have in mind that it is a right angle triangle. So this is our ladder, this is our vertical wall. The angle the ladder makes with the floor is 60 degrees. And then the distance of the ladder, the foot of the ladder from the wall is 8 meters. Let's call this A, let's call this B, let's call this C. So the question says calculate the length of the ladder. Let's call the length of the ladder L. So what information do we have about this scenario? We have the adjacent side, we don't have the opposite side, and then we are asked to find the hypotenuse side. So what comes to mind is the cosine of this angle 60, which is equal to adjacent, that's 8 over hypotenuse side, which is L. So to find L, we'll cross multiply and divide. This will give us 8 divided by cos 60. L is equal to 8 over 0.5, which is equal to 16 meters. It's quite straightforward. So our next problem says a hawk on top of a tree 20 meters high views a chick on the ground at an angle of 39 degrees. Find the distance of the chick from the bottom of the tree. So this simply tells us that it's a case of angle of depression. So we have a triangle this way. This is the line of sight of that hawk. The chick is here. Let's call this A, B, and C. The angle of depression is 39 degrees. The height of the tree is 20 meters. Now we are asked to find the distance of the chick, as here, from the bottom of the tree, line AB or X. So how do we go about it? If this angle is 39 degrees, automatically it means that this is 39 degrees because alternate angles are what? Equal. So using this angle as our reference, which of the ratios should we use? This is the opposite side of this angle, and this is the adjacent side of this angle. So it simply means we'll use the tangent of this. So tan 39 is equal to opposite, which is 20 over adjacent, which is x. X becomes, we cross multiply and then divide. 20 divided by tan 39. X is equal to 20 divided by tan 39 is 0.8098, which is equal to 24.69 meters. So we have solved one problem on angle of elevation, and we have solved another problem on angle of depression. So please do well to solve other problems on angle of elevation and depression.